I want to believe we have an awesome day today. All right, so today we are going to continue from where we stopped the last time on the variation. Don't forget the last time we looked at joint variation, and also we looked at indirect variation. Today we are going to be moving forward. We look at some technical questions on that joint variation, okay? And from there we move down to partial variation. That's going to be the last subtopic we are going to be doing on the variation. So if you are just joining this class for the first time, I want you to subscribe to this channel and also give a thumb to the class if you find this class interesting. Okay, so other students that are regular in this class, please, I want you to invite your friends. Let them know the class have started because we are going to be starting anytime from now. Okay, so we have some questions that we are going to treat today. They are technical questions, and I can tell you at the end of the class, you should be able to solve any question. For those of you that want to write WAEC, Neco, you want to write an external exam, okay? So I can assure you this class is going to be helpful for you. So get your writing materials ready and get yourself set for the class. Don't forget, invite somebody. Invite somebody. So let's wait for a few minutes before we commence the class. All right. Okay. So this is the question. I want to believe we have a good number on the platform. Okay. Yeah. All right. As you are joining the class, I want you to give the class a thumb. Okay. Give the class a thumb as you are joining the class. Okay. So we are going to be looking at this question. All right. You have if x varies directly as y raised to the power of n and x equals to 4 when y equals to 2 and x equals to 16 when y equals to 8. Find the relationship between x and y and find x when y equals to 0.4. All right. I'm very sure when students see this type of question, they begin to ask, what type of question is this? Is it direct or indirect? Okay, so this question is direct variation. I know you begin to ask yourself about this n that we have here. Let's see how this problem is going to be solved here. So before we commence, ensure you invite your friends so that we are going to learn together. So I want us to have a good number of viewers on this channel. Let's kindly share this video with our friends and let's get set for the class. Okay, so and I will also employ if you are just joining for the first time. Okay, so ensure that you subscribe to this channel and also give a thumb to the class if you find the class interesting. Okay, so now let's look at this question. Now, if x varies directly as y raised to the power of n, if x varies directly as y raised to the power of n. Now, if you have this variation, what it means is that then x equals to k y raised to the power of n, where k is a constant. Can you see that? That is the first step. Now, look at the question. You are given that x is 4 when y is 2. Now, we plug in the values of x and y into this equation. Can we do that? All right, so x is 4. You have 4 equals to k times y. What is y? Y is 2. 2 raised to the power of n. All right, so now the first thing we do when you have this type of equation is to find the proportionality constant, and that is what we want to do now. We want to find the value of k here. All right, so what do we do from here? We divide both sides by the coefficient of k, and that is what? 2 raised to the power of n. Now let's do that. So you have 4 over 2 raised to the power of n equals to k times 2 raised to the power of n over 2 raised to the power of n. So you can see what we did to both sides now. So we divided 2 raised to the power of n by both sides. So we divide this by 2 raised to the power of n, 2 raised to the power of n. So let's see. Now this cancel this. So we have k equals to 4 over 2 raised to the power of n. Now don't forget 4 can be written as 2 raised to the power of 2. So now this is the same thing as writing 2 raised to the power of 2 divided by 2 raised to the power of n. Can you see that? So because this division now is the same thing as this. So and your law of indices, when dividing, what do you do to the power? You subtract the power. So that means k is the same thing as 2 raised to the power. Just write 1, 2, so you have 2 minus n. So, and this is the value of k. All right. So now we plug in the value of k into this equation. So it becomes x equals to 2 raised to the power of 2 minus n, y raised to the power of n. Can you see that? Now we still have n in the equation. So we have to look at what we are given here again. You can see y is 2, x is 16. So we plug in this value into this equation again. Let's do that. X is what? 16 equals to 2 raised to the power of 2 minus n. Y is what? Y is 2. Okay? Okay, is y2, y is 16. Y is okay, x is 16 when y is 8. Okay, sorry. So then y is 8 now. So let's plug in that. We have 8 raised to the power of n. Okay. Now we have used this. Now this is the second pair, this and this. All right. Now when you look at the numbers we have here, they are multiple of 2. So you can express them in index form. So I'm expressing this as 2 raised to the power of 4 equals to 2 raised to the power of 2 minus n. This is the same thing as times 2 raised to the power of 3. 8 is the same thing as 2 raised to the power of 3. And we have n here. Okay. So now we are joining this and this together using law of indices. So when multiplying, you add the powers together, provided the base is the same. Okay, so here we have 2 raised to the power of 4 equals to 2 raised to the power of 2 minus n plus 3n. Hope you understand that. Okay, so from here, now you can equate the powers. Since the base is the same, so you equate the powers. So you have 4 equals to 2. Now look at this. Minus n plus 3n. That gives you plus 2n. It's just like you are taking away n from 3n. So you have 2n. So this is what we have. So here, let's collect the like terms. We have 4 minus 2 equals to 2n. Okay, so from here, what do we have from here? So we have 2 equals to 4 minus 2 is 2 equals to 2n. So here you divide both sides by 2. So you have 2 over 2 equals to n. Therefore, n equals to what? 1. So that is the value of n. Then you can now answer this first question. Now, you have to find the relationship between x and y. So you just come here. Where do we have that connecting formula? So this is it. So you come here. This is what you are going to write out. So the only thing that will be changing there is n. So we have x equals to 2 raised to the power of 2 minus 1, y raised to the power of 1. You get that? Because n is 1. So just plug in the value of n to this equation. So the relationship will now be 2x equals to, this is 2 raised to the power of 1. Because 2 minus 1 is 1. So 2 raised to the power of 1 is the same thing as 2. So you have y. So that means the relationship between x and y is this. So that is what is required. Now let us look at the next thing. Now the question asks us to find x when y is 0.4. Find x when y is 0.4. So you just plug in the value of y into this equation. So let's do that. And this is the second part. We have x equals to 2 times 0.4. Okay, so now when you do that, what do you have? What's going to be the value of x? So now x equals to 0.8. So that's going to be the answer, which is also the same thing as 8 over 10 or 4 over 5. So which is the same thing as 4 over 5. Yes, that is the end of the equation. So I want to believe you understand what we have here. All right, so before I give you the next question, before we solve the next question, so I want to ask you this. You're going to do that for me. You find x, or let's say find y when x equals to 2 over 3. Find y when x equals to 2 over 3. X equals to 2 over 3. So you do that and let me have your answer in the comment section. Yeah, can you quickly do that now? Let's see. What do you have? Making use of the connecting formula here. I want to believe we know the connecting formula. Connecting formula is x equals to 2y. All right. Okay, let's see what we have here. All right, I can see Olorunfunmi. Yes, yours is 4/3. Okay, can we wait for others? Yes, what do you have? Any other person? I can see Aishat here. I can also see Adekunle here. Okay, Oluwatosin, yes. Y is 1/3. Okay, any other person? Yes, thank you, Oluwatosin. Yes, I can see your message. Thank you. Okay. Yes, another person. Find y when x is 2/3. Is there any other person that is giving an answer? Another person? Okay. All right. So I think what I have there is 1/3. Let's see if that is correct. So all we just need to do is just to substitute inside this connecting formula. So this x is 2/3 equals to 2 times y. So you divide both sides by 2. That's all. So that means you multiply this one by 1/2. This one times 1/2. This cancel this. This cancel this. So you have 1/3 equals to y. Okay, so that is going to be the correct answer to that problem. All right, I need to show you how marks will be awarded to this question I just gave you. All right, now for substituting inside the connecting formula, there will be a method mark 1 for that. For getting constant to be 2 raised to the power of 2 minus n, an accuracy mark for getting this. For substituting inside this formula that we have here, so there's a block mark for that. Okay, and for substituting inside this equation, there's another method mark for that. Now for equating the powers, we have a method mark, and for getting the answer, A1. For getting the connecting formula which the question asks for, we have another A1. Right, for substituting M1 and for getting the final answer is A1. So let's count how many marks altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 marks altogether. Okay. All right. So that is the first question we are looking at. Now let's look at the second question. See how the question looks like. Question 2. Okay, yes. This is another question on the joint variation. So immediately after this one, we move down to partial variation. Now, P varies jointly as square root of R and 2/3 of Q. Now, if P equals to 3, Q equals to 3, while R equals to 9, find the law of variation. Roman numeral 2, R in terms of P and Q, and the third one, R, when P equals to 2 and Q equals to 5. So how do you solve this type of problem? Now, the first thing to do is to express this mathematically. All right, so now let's do that. P varies. This is symbol for variation. P varies jointly as square root of R. This is square root of R. Square root of R. Okay. And 2/3 of Q. So that is times 2/3. 2/3. 1/3 of Q. So like this. Okay, so I can tidy it up now as P varies as 2Q square root of R over 3. Okay, so this is the combined inequality. All right, so if you have this, then it implies that P equals to 2Q K Q square root of R over 3, where K is a constant. Can you see what we just did now? Look at the variation. We just introduced the proportionality constants there. So you put it here. All right. So now the next thing is to plug in the values of P, Q, R. Now let's see. P is 3, Q is 3, R is 9. So let's plug in that. We have P is 3, we have 3 equals to 2 times Q is also 3, 3 times K times square root of 9. R is 9 all over 3. Okay, so see, this will cancel this. So we are left with 3 over 1. 3 over 1 is same thing as 3 equals to, or we just simply write 3 since we don't have fraction here again. 2 times K times, what is square root of 9? That is 3. So you have 3. Okay. So now this is 3 equals to 6K. 2 times K, 2K times 3, that's 6K. So you divide both sides by the coefficient of K that you're looking for, and that's 6. We divide both sides by 6, so you have 3 over 6 equals to K. So therefore, K equals to what? 1 over 2. So that is the proportionality constant. So we plug in this into this equation to get the law of variation. So now let's substitute now. We have P equals to 2Q. Now K is 1 over 2. So we just write times 1, okay, over 2. We have times QR times 3, because we have 3 here. So this is the 3. Now this 1 over 2, this 1 over 2. You can see that. And we have the Q and 2. So you see this, we cancel this. So we now have P equals to Q square root of R over 3 is the required law. Okay, this is the required law. All right, now the question go further, saying that you find R in terms of P and Q. So what that means is you make R to be the subject of the formula. Now, how do we do that? Let's make R the subject of the formula. Okay, so now here you just cross multiply. So you have, this one is like over 1. So we have Q square root of R equals to, now use this to multiply this. That gives you what? 3P. You have 3P. So next you divide both sides by Q. So you have square root of R equals to 3P over Q. Okay, what's the next thing? You take square of both sides. So when you square this, you have R. So you square this, you have 3P over Q. Okay, raised to the power of 2. So you square this side and you also square this. When you square this, you have R. Okay, so this is the second task, Roman numeral 2. Now let's look at the third one, Roman numeral 3. You have to find R when P is 2, Q is 5. So let's plug in this value into this equation so that we're able to get R. So Roman numeral 3, we have R equals to 3 times P is what? 2 over Q is what? 5, all squared. And that is the same thing as 3 times 2 is 6 over 5 raised to the power of 2. Okay, so what will that give you? When you square 6, you have what? 36 over what? 25. So now, this is an improper fraction, so we change it to mixed fraction. So now, what do we have now? So 25 goes in 36. That is 1. Remainder what? Remainder 9. Okay, over 25. Okay, is it 9 or 11? I think that should be 11. Okay, so that is 11. All right, so one number 11 over 25 is the answer to that problem. So now we are done with the problem. So how do we award marks to this question? So now for substituting the value of P, Q, R into this equation, so we have M1. For getting the answer, we have A1. So for getting the connecting formula, so we have A1, or the law of variation, A1. For substituting, we have M1. Okay, here you are making Y to be the source of the formula for solving M1 and for getting the answer A1. And for substituting here, we have M1, and for getting the answer, we have A1. How many marks altogether? I think that's 7. So let's count. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 marks all together. So I want to believe you guys are learning. All right. So don't forget, if you are just joining this class for the first time, ensure you subscribe to the channel and also give a thumb to the class. All right. So we are moving down to the last subtopic, okay, which is partial variation. So let's look at some questions under partial variation. All right, okay, so this is another question under partial variation. I want to believe we are all there. We can all see the board clearly, right? Okay, now let us see how do we solve this problem. Now, C is partly constant and partly varies as M. If C is 45 when M is 10 and C is 87 when M is 24, find the equation connecting C and M. So how do we solve this problem? Now look at it. C is partly constant. That means C equals to A. This A is the constant. C is partly constant. It means C equals to A. A is a constant. And means plus in this sense. And partly varies as M. Partly varies as M. So M is a variable. Once you write a variable here, you have to introduce a constant as well. Let's call the second constant B. So we write that A comma B are constants. They are constants. So now the next thing now is to plug in the values of C and M given in the question. So we plug that into the equation we have here. So now let's look at it. C is 45, while M is 10. C is 45, Y is M. So we have 45 equals to A plus M is 10. So we have 10B. So we call this one equation 1. So in partial variation question, we used to have two equations that we solve simultaneously. So this is the first one. Now let us look at it. The second equation we'll be having now, we plug in the value of C and what? And M into this equation again. Can we do that? So C is 87. 87 equals to A plus, what is M? 24B. So we call this one equation 2. All right, so what is the next thing to do? We have to solve these two equations simultaneously. So we subtract one from the other. Okay, here we say subtract equation 1 from 2. So you can also do it in the other way around. So just pick anyone. So you take away this from this. Okay, so now let us take 45 away from this. So what is it going to be? Okay, so that is going to be 42. Okay, that will be 42 equals to, now A minus A, that is 0. So 24B minus 10B, that is what? That is 14B. So here you can divide both sides by 14. So you have 42 over 14 equals to B. So what is B? Now that's going to be 3. Okay? All right, so now let's get the value of A. So just insert this B into any of the equations, but let's pick equation 1. All right, so we have 45 equals to A plus 10B. 10B. So instead of writing B, I'm plugging the value of B, which is 3. So we have 3 here. Okay, so we have 45 equals to A plus what? 30. So we have A equals to, so now let's transpose this to this side. We have 45 minus 30. Okay, so we have A equals to 15. So now we now have the value of the constants, B and A. So now we substitute the constants into this equation to get the connecting equation. Okay, so let's substitute here. So we have C equals to A. A is what? 15 plus MB. B is 3. That's going to be 3B. 3B. Oh, 3M. Sorry, 3M. 3M because B is actually 3. So that's going to be 3M. So this is now the equation connecting C and M. Is the equation connecting C and M. Okay. So this is the equation connecting C and M. All right, now let's look at the second part of the question. You have to find C when M is 18. Find C when M is 18. All right, so here we have C equals to 15 plus 3M. So when M is 18, so what do we have? We have C equals to 15 plus 3 times 18. Okay, so now we have C equals to 15 plus, so what is 3 times that? That's 54. Okay, so now you can add together. So when you add together, what do you have? You have 69 as the answer. All right, so and that is the answer to the problem. Okay, so I want to believe we understand the explanation here. So I want you to respond to this solution. Is there any problem? Do we all get that? Okay, being the first question, we are solving under partial variation. So do we all get the explanation to that problem? Okay. All right, that's good. Now let's move on to another question here under partial variation. Okay, it's a very lengthy question. So that is the question on the board. I want to believe we can all see the board. Okay, yeah. All right, so can we all see the board? Is the board clear enough? Can we all see the board? Okay, okay. Yeah, all right. So now let's look at the problem we have here. Now the cost of maintaining a car is partly constant and partly varies with the distance traveled in a given month. Now the cost C for a particular month was 1,250 naira when the distance D traveled was 300 kilometers. In another month, the cost was 3,500 naira for a distance of 1,200 kilometers. So find the law of variation. Now the second part of the question, find the cost for a journey of 1,600 kilometers. So how do we solve this problem? The first thing we need to know is to identify the two things that is being varied here. Now in the question you can see the cost of maintaining a car is partly constant and partly varies with the distance traveled. So these are the things, these are the parameters. We have cost of maintaining a car and the what? And the distance traveled. These are the two parameters that is being varied here. And as you can see, the cost is C, while the distance traveled is D in the question. So now let us write now. So solution. Now the cost C, cost of maintaining a car is partly constant. That means it's equals to a constant. Let's represent that constant with small letter A. It's partly constant and that's plus partly varies with the distance. Partly varies with the distance. And don't forget the distance is D here. So partly varies with the distance. Okay, so we need to introduce a constant here because this is a variable. So we have another constant here. Okay, where A, comma B are constants. They are both constants. All right, now let's move down here. Now the cost C for a particular month was 1,250 naira. So that is C is 1,250 equals to A plus, now when the distance D traveled is 300. Hope you understand that. That is when C is 1,250, D is 300. So let's plug in the value of D. That is going to be 300B. We call this one equation 1. Now let's read on. Now in another month, the cost was 3,500 for a distance of 1,200. You get that? Okay, so that means C is 3,500. So we have here, you are plugging in the value of C here, 3,500 equals to A plus D. What is D? The distance traveled here now is 1,200. 1,200B. We call this one equation 2. All right, so now let's solve these two equations. Now you take this from this. So what do we have when we take this? Well, let's say subtract 1 from 2. That is equation 1 from equation 2. So when you do that, what do you have? You have what? 3,500 minus this, you have 2,250. Okay, so equals to A minus A. And this one gives you 1,000, no, that's 900. 900b. Okay, so we now have b to be equals to 2250 over 900. Okay, so now let's simplify this. Now this will cancel this. Now let's see, 5 can go. Now 5 goes in 22. You have what? You have 4. Remainder 2. 5 goes in 25 is 5. Now 5 goes in 9 is 1. And 5 goes in 40, that is 8. 5 goes in 40, that is 8. Now let's look at this. We can still simplify further. Now we have 45 here because that's something as 45 over 18. So let's see. 3 goes here is 15. Okay. And 3 goes in 18. That's going to be what? 6. Can you see that? Now we can still simplify further. So 3 goes here is 5. And 3 goes here is what? Is 2. So that means B equals to 5 over 2. All right. So now let's move on. Let's plug in the value of B into any of the equations. Let's say equation 1. So we have 1250 equals to A plus 300 times 5 over 2. You know, the value of B here, that we're supposed to write here is 5 over 2. So you just plug it in. So you have 1250 equals to A plus, now 2 goes here 1, 2 goes here is 150. So you have 150 times 5. Still have this 5 here. Okay, so let's clean this side. Okay, so now this gives us what? 1250 equals to A plus. Now, when you multiply this, what do you have? 6, that's 750. You have 750. So you can move this one here. You have 1250 minus 750. 750 equals to A. So what's going to be the answer to that? So we have what? So when you say this minus this minus this, we have 0, 0, 12 minus that, that's 5. Okay, so that means we have 500. So A is 500. Okay, so now we can now get the connecting formula. Connecting formula. So you come down here. So this is what you are writing out. So you have C equals to A is 500. B is what? What is B? That is 5 over 2. And you can always put your D here. D. So that's the first task. This is the law of variation. So the next task is you have to find the cost of the journey when this distance is traveled. So what's going to be the cost of the journey? Okay, so now I want you to try that and tell me, plug in this value and tell me what's going to be the cost of the journey. So let me engage you a little bit. So find the cost of traveling for this distance 1,600 kilometers when this is the connecting formula, the law of variation. Okay, can you quickly do that and drop your answer in the comment section? Okay, I can see someone dropping an answer, 4,500. Okay, that's Golan. Okay, any other person? Any other person with an answer? Okay, anyone, another person? Okay, I think I can see Motrayo here. Yes, I can see Adebayo Emmanuel. Yes. Who else? Okay. Yes, Oluwatosin. What's your answer? I can see Olawale Gabriel. I can also see Richard Martin. Yes. Can we drop? What do you have? Okay, because of our time, because we need to move very fast. Okay, so let's plug in and do this together. So when this distance is covered, 1,600. So we plug in the value. We have 500 plus 5 over 2 times 16, 1,600. Okay, so now that is going to give us 500 plus. Now let's reduce this. 2 goes here 1. 2 goes in 16 is 8. And we have 0, 0. Okay, so that means we'll be having 5 times 800. Okay, so what is 5 times 800? So just multiply 5 times 5 times 8. So we have 500 plus 5 times 8 is 40. So we just put the remaining 2 there. Okay, so and that gives you 4,500. Now it's going to be in naira. So this is going to be naira. So don't forget, whenever you are writing money, it should be in 2 DP. So let's put 0.00. And this is going to be the answer to the problem. So I want to believe you can see the solution to the problem is as simple as what we just did. Okay, so we are going to be rounding up the class now. I want to believe we all enjoy the class. All right, so today I don't know what happened, so we don't really have good number on the platform. So always try and invite your friends anytime we're on here. All right, let's have good number of learners here. Okay, so I really appreciate all of you, those of you that are here, and I want to believe if you continue with mathematics, you will find out that it's enjoyable and it's just all about fun. Okay, so tomorrow is going to be another wonderful time. So let's make it a date. We'll meet around this time tomorrow. And don't forget to share with your mates in the school. Let them know about the GMats class. Okay, so thank you very much for watching. Bye bye. Okay, Martin, I can see you. Okay, from Jamaica. It's my pleasure. All right. How is Jamaica? Okay, I want to believe you enjoy the class. All right, that is very good. I'm happy seeing you on the platform.